first one. So a car is moving forward and then turns around. So what we need to do is we need to draw a little graph. So I'm just going to draw one line down and one line over, and then I'm just going to use a different color for the actual line on the graph. Okay. So a car moves forward, so that means we need to have a positive slope, and then a car moves backward, so it turns around. So that means we would have a negative slope. And ideally these lines are touching, but I know it can be kind of tricky in Cami. Okay, so for the second one, two airplanes go away from each other, turn around, then go back towards each other. Okay, so this one has a lot of different movements. So I'm going to make this graph pretty big. Okay, and we have two different airplanes. So I'm just going to do one airplane with purple. So they go away from each other, and then they move away from each other and then back towards each other. Okay, and remember, we always want to think of this on a straight line. So if they're first moving away from each other, and I'm just using different colors to denote different objects, and then they're moving towards each other. Okay. All right, so for this next one, now we have some numbers. So I do need to add some sort of an axis here. They start 5 meters away from each other and both run towards position 0. Once they get there, they stand still. Okay, so I'm just going to do some random lines here, and I need to add in some numbers. So let's say 5 meters and 10 meters. Okay, and we have two runners. So back down to shapes. So basically they just go down to position 0, and then they are standing still. And I want to talk through this after I draw this. So a couple of things here. If you are standing still, that means that your position is going to be the same for all of the time that you are standing still, okay? So that's why if you are standing still on a position time graph, your line is going to be a flat line. So do we see that this line here, okay, once they meet the x-axis and they're just kind of with the x-axis, the y-axis value for both the green line here and the red line are both identical. Okay. All right, for the next one. After 10 seconds, a dune buggy's displacement is 0 meters. So your displacement So this is a word that we haven't actually talked about yet. Displacement is the difference between start and finish. So for this, you only compare starting point and end point. Let me just draw like a little kind of like arrow from this just so that we know that this is defining that. Okay. So an example of this, if I'm sitting in my chair at the front of the room and then I stand up and I walk around the room for like 5 minutes and then I come back and I sit in the exact same spot, my displacement is 0 because I started and ended at the same place. If I am starting in my chair and I stand up and walk all the way around, and then I end up 1 meter away from my original location, my displacement is 1 meter. Okay, so all we care about with displacement is the start and the finish. So for this one, there are a couple of different ways that you could show this. Basically, you just have to start and end in the same position. So if we start here, then we need to end at that same position. Okay? And I'm just going to make a little note of that. Oops. If displacement is 0, you start and end at the same location. Okay, so for number 5, 2 trains are moving in the same direction. They left the station at the same time, but one is faster. So they left a station at the same time, so that means they are, whoops, I did not mean to do that. Undo. Go back to shapes. So they're leaving at the same time, going in the same direction, but one is moving faster. So that means that this is the graph that looks like this. And you'll start to notice that you see a lot of these same graphs kind of happen over and over again. Okay, so just kind of some text in here to break down what's going on here. So from this station equals same starting point. One is faster equals one has a steeper slope. Same direction equals both moving forward or backward. So for this example, let me just erase that line and shorten it a little bit. So this is one way to answer this. Another way to answer this would look like this, where we have so both are moving in the same direction from the same starting point. One is moving, the red one is moving faster. So just to kind of make sure that's going with both of these. Okay. Okay, number 6. A car comes up from behind and rear ends a truck that was sitting at a stoplight. The car comes to a dead stop upon crashing into the truck. Okay, so again, we have 2 different objects here. The car, oops, just trying to underline it so we know what color these things are, and the truck. So the truck is just sitting at a stoplight. So if you're just sitting at a stoplight, you're in one location, right? So your position is constant. So the truck is just sitting there. The car comes up behind So the car comes to the location of the truck, and then the car crashes into the truck. So it's something like this. And we don't know, and then they're in the same location. We don't know if the car is moving forward or backward. So you could have also had the car line be a negative line from the top, okay? And that would have been just as correct. Okay, so for this next one, so a high speed chase on the highway, a blue car, okay, so let's use blue for that. A blue car is chasing a red car. Both the blue car and the red car are moving forward. Okay, so we know that forward means that we have a positive slope. The red car is moving faster. Let me just kind of shift these guys. Oops. Yeah, that'll be okay. So forward equals positive slope. I'm just trying to make sure that we get where these things are, what these comments are linked to. So forward equals positive slope. And then if we are moving faster, that means that we have a steeper slope. Okay. So the red car is moving faster than the blue car, but they're both going the same direction. So I need to complete my graph. Draw blue car first. Oops. So blue car is chasing the red car, which means that the blue car's location is behind the red car. And the red car is moving faster. Okay, so red car is ahead of the blue car and is moving faster.